Welcome, everyone. Sorry we're running a couple of minutes behind here, but I think we've got an exciting talk here today on thinking about modern relevance and how we go about, especially as search engineers and businesses, building out a better search experience. And I think better search experience, of course, means a lot of things to a lot of people, and it's changed a lot over the years. So what I thought I would do is just kind of start off by thinking about how this has traditionally been done. And I think, we start with the query, and we start with users interacting with the system. Namely, I've got a user come in, they're looking for something pretty simple, like they want a case for an iPad. And if I'm a good search engineer, maybe I've done this work in Solr or a related search engine, I might come up with something like what you see here. I turn that iPad case into perhaps a phrase query. I perhaps use some synonyms and related things. And I can go do a bunch of work to kind of craft this custom query, if you will, that I can submit to my search engine. And then I might get back a set of results. If this is a particular data set that I've built out just using Fusion and Solr underneath the hood. And if I do that query, I come up with something like this, where, my number one result, you can see there, it's got all the proper things in there. I've got Apple, I've got iPad, I've got case in there. And so I've essentially done keyword matching, but you can see number one there is Cleveland Browns, and number 15 is the Minnesota Vikings. And, I don't know about you, but when I look at the data, when we dig in on what's going on, I think we all kind of agree that it's a little bit odd that the Cleveland Browns are showing up. Namely, if you actually look in and were to look at a hypothetical e-commerce site, you might just find that, Cleveland Browns gear, accessories, etc., doesn't sell all that well because, we all know, of course, me being a humble Minnesota Vikings fan, that the Vikings are actually the best team. And when, in fact, we look at the data, the Vikings data shows, or the data shows that the Vikings really should be at the top of the results because, frankly, at the end of the day, it's what sells more. It's what most people are interested in when they look for things like iPad case. And in fact, this is a very common scenario that I see when I engage with customers across all kinds of different search disciplines, whether it's retail or enterprise search, et cetera. It's namely this question of how do I get better results? Hey, I think, Vikings, according to my data, should be at the top, but it's just not showing up. And if you did that analysis across a lot of different queries, you would see that exact problem. And so then the question becomes, okay, I'm a search developer, I'm a business analyst, I'm somebody who cares about making search better. You ask yourself, well, what do we do? Well, first off, if you're a loyal Solr user, you might go read the manual. And you might then say, oh, well, I've got the perfect solution for this. At index time, I'm going to add this thing called the document boost. So anytime a document comes in with the word Vikings in it, I'm going to boost that document by 100. Or perhaps I know I can do some tricks at query time to boost Vikings, et cetera. Maybe I put some fancy query parsing in. And essentially I can kind of play around with all the different boosts and build up this rule system around it. And I think if anybody's been doing search for a while, you know that this is how, this is kind of the dirty little secret of relevance tuning behind the scenes. And it's not to say it's necessarily bad, but it's pretty cumbersome. It's pretty intensive. But let's say, for instance, you weren't happy with even those results because, for instance, I might want to, instead of it just being Vikings, maybe I want it to be Minnesota anytime the query has Minnesota or the document has Minnesota, or maybe it's the Vikes because the Vikes are the shorthand version of Vikings. And so you get into all these kinds of edge cases. And even after doing all of this, you might find that the system still isn't performing the way you want. And so you being a smart engineer or a smart search person here, you might dig in even deeper. And you might say, oh, well, Solr's got this thing called explains in it, or I can do debug query operations. And then you might see something like this on the page. Anybody who's dealt with search knows that most of these engines have these kinds of things where you can look at and figure out, oh, well, this word matches here, etc. I'm not expecting you to read all of the content but on this particular screen, but just to show you an idea of what's involved in typically debugging why a particular query matches the way it does. And this, of course, is useful. I've done this myself many, many times. And it's not to say, I'm not trying to suggest that any of this kind of stuff goes away. It's just kind of a pretty cumbersome process when it comes to search. And even after looking at all of these debug statements, you might find that you're still just not getting what you want. And so you might then say, well, I'm going to go ask the experts. There's lots of good sources out there that cover how do we tune all of these systems. I'll put in a shameless self-plug for my own book here, which has some sections on tuning relevance, but of course there's lots of other books, including the one you see on their right, which is focused solely on getting better, more relevant search. And so you can dig in and you can become much more of an expert. You might then start to learn what's going on in the search engine. Those of you who have been in the Solr space, the Lucene space, the search space in general, you probably have heard terms like TF, IDF, and you might start to understand some of the math involved. Or if you were paying attention in the Lucene and Solr community over the past year, you might know that, for instance, we switched to using a new formula for scoring underneath the hood called BM25. For those who care about the math, there it all is in all of its glory. Not expecting, don't worry, there won't be a quiz on BM25 anytime soon. But, you know, the idea here is you're starting to dig in at a much deeper level. Like, I'm going to solve this relevance problem, and the way I'm going to do that is I'm going to figure out all the math. I'm going to figure out all the rules. I can do all of those kinds of things. And you might then even lead up to the next level, which we typically see as search engineers, is how do I start to actually measure whether any of this stuff is any good? Because, you know, let's face it, we can spend all day tweaking and tuning all these different knobs and dials that a system like Solr comes with. But the reality is if you don't have any way of measuring whether it's effective or not, you're not going to ever be done, right? And then, of course, the real problem here is this is a never-ending problem, right? Lather, rinse, repeat on all of these things. You're constantly adding new rules. You're constantly looking at these explains, et cetera. And I think we all just kind of agree that that's a lot of work, right? And so then you might ask yourself, well, how do I get out of doing all of that work? And I think that's where, you know, you often see this light bulb moment of modern search techniques. And namely, that light bulb moment is often powered by the simple insight of asking yourself, what would Google do? And the reality is, of course, Google has a ton of really smart engineers, and they're doing all kinds of really fancy things. And of course, they have a lot of data to work with. But at the end of the day, one of the things that, you know, we all know really powers Google is us. People are constantly telling Google what to do, what's important, what matters in the data, how are people interacting with it, what's the whole process a person goes through as they interact with that data. And that really, I think, leads to kind of this insight around where modern search relevance is at these days. And I kind of think about it as this stack that, or this continuum that goes from pure guessing, namely I could just throw any document up on the page, all the way up through to this magical experience where the search engine knows exactly what I'm looking for. It's like it's mind reading, and it retrieves back just those exact results. And the reality is we all as search engineers are somewhere in between here. If you think about a tool like Lucene, an API, Java library like Lucene, a search system like Solr or related search pieces, they really only solve, you know, maybe half, maybe 60% of this particular problem around how do we get better, more modern results out of a search engine. And then, things like faceting and did you mean and kind of these discovery aids, if you will, can help us get another percentage. And of course, as I mentioned earlier, we're never really going to get rid of rules or any domain-specific knowledge as we build out these systems. But I think, frankly, like these days, the way most people are driving this more modern search experience is really to leverage machine learning, quote-unquote AI, if you will, the natural language processing, statistical analysis. Essentially, like Google, we're all trying to leverage what users are telling us about the data such that we can feed it back into the search engine. And when I look at like our best-in-class customers here at Lucidworks, it's those who are most successful are the ones who can go across this entire stack. Right? They can deploy and scale the core information theory, the Solr part of it, the Fusion, the core bits, the Fusion server bits, if you will. But then they also can layer on their own knowledge, the machine learning things, and all of that. And then, of course, the reality is at the end of the day, we're never going to be perfect. This is an ongoing process, frankly, because, users don't always even know what they want when they do a search. And so I tend to think about then how do we put all of this in pun intended context, right? And I tend to think about modern relevance then going across three key pieces. First off, content is still very, very important. Content is and always will be king, right? If you don't have the content in the system, it doesn't matter how good all of the other parts of your system are. You can't retrieve something that isn't in the system. And so, first and foremost, this is where most search engines in the past have stopped, right? Like if you just take Solr out of the box without any of the learning to rank or any of the machine learning bits or an Elastic or any of these other legacy systems, you find that they stop at the content side of the equation. Namely, you get text matching, you get keywords, you get your 10 blue links, you get your facets, maybe you can overlay some boosting and blocking and some basic rules, but you're often falling short, in my opinion, on the overall capabilities that you could be delivering to your customer. And that's really where these second two to the right come in, namely the collaboration side. Think about it as just like, what are all my users telling me about my data? And the really cool thing about that user feedback data is it can be leveraged in a number of different ways. If you take a step back beyond just search, if you think about it, is the same data that makes for better search is the same data that makes for recommendations, personalization, query intent, query understanding, better spell checking. At the end of the day, it also is what powers your analytics. And that's all of your collaborative data. That's the data that users are giving you, the signals, if you will, that say, hey, this particular piece of content is interesting. And then, of course, to kind of round it out is the contextual side of the equation, namely, who is this user? What do we know about them? What have they done with us in the past? What market are they in? Are they, what customer segment do they fit in? Are they a value customer? Are they a luxury customer? Are they the CEO of the company, or do they work in the mailroom? All of those kinds of things can be leveraged as factors in how do we build a smarter, more modern search engine. And so what does this all then mean in the real world? How do I translate all of this kind of pie in the sky, high level, hey, yeah, I need to know and do machine learning? How do I translate that into a better, more modern search engine? And for me, like, I start obviously with content coming in. So we've got our content coming in, we've extracted it out. And I think, these days what you're seeing is more and more search applications applying some of these smarter machine learning NLP systems right to the data as it's flowing in. And the cool thing here on the NLP and machine learning space is this stuff has finally gotten practical. That's not to say it's perfect. I've been working in this space for a long time. I've seen a lot of really good demos in the NLP and machine learning space, but you're just starting to see now, and frankly, thanks to all of the data we're collecting, all the user feedback we're collecting, you're starting to see this stuff really shine, really be customizable to the particular domains that we're after, not just general, say, news text domains. And so as that data comes in, I might go do a whole bunch of things like named entity recognition, topic detection, clustering. I might use some synonym expansion capabilities like Word2Vec, and then still pass those through my domain rules, etc. And ultimately, I put that data into Solr. And now I have kind of a starting representation of my content. And then what you often see, and this is something we really strive to enable in Fusion, is you can't just think about it being done at that point, right? Like these machine learning models, these NLP models, you've got to think about how do I constantly learn and improve from them. And so for us, the way we go about doing this in Fusion is we then take what's in Solr, we load it up to Spark, and now we're kind of creating this virtuous cycle whereby, based off of the analysis we've done, based off of what users are telling us, we can enrich and extend those models and then deploy them back in. And for us in Fusion, we keep all of that data right back in Solr. So right alongside all of your core content is also all of your machine learning stuff. And the really cool thing about that is I've just greatly shortened your time to develop and deliver smarts in the indexing process by keeping all of those models right next to the system. I don't have to go talk to my data scientists who are off doing it in Py or R, Python or R, or one of those kinds of things. I can just have them build it right on the data where I'm capturing it. So that kind of gets at the indexing side. Basically, how do I leverage this machine learning stuff at indexing time to make the system smarter based off of what users are telling me? I can then, at the query time, think about doing search in a much broader context. And I think really the key thing that you see really making a difference in search these days as it relates to better understanding users and leveraging machine learning in these more modern relevant search systems that are really striving for high-end relevance is you see this focus on, let me try to predict what the user is asking for. What is the intent behind this? Is the user asking to buy something? Do they want support? Do they want to just do some comparisons? Are they looking for an expert, or are they looking for data to support a particular viewpoint, right? Depending on your use case, query intent can mean a lot of different things. But the key thing for you all who are building out these search applications is, can you predict upfront what this user is asking for? And when it comes to query intent, I tend to think about it at least a couple of different levels. First off, there's kind of this strategic intent in my mind, which says, what's the label I'm going to apply to this query? What's the overall thing that I think this user is asking for? Are they searching for a particular product? Are they looking for support? Is it spam? Is it a comparison intent? Are they looking for a person? Are they looking for a particular kind of document? So that's kind of the strategic thing, and you can think about it as the query comes in. I just, right off the bat, I label that intent, and I say, here's my best guess. And then I start to break down that query, and I look at the tactical parts of the intent, right? This particular part of the query is a brand. This particular part of the query is dimension or attribute data. This particular part of the query is a person's name. Right? And it's those tactical components that really help me drive building a practical search system that is going to be of much higher quality relevance. And of course, there's also the semantic levels here of relationships in the query. Is this actually a person? What is it relating to? Is this person looking for a particular relationship with a user? learning and understanding those things can all flow out from the query intent as well. Once I have that intent, I can then start to make more informed decisions. I can start to look at prior behaviors. I can start to bring in my prior knowledge around perhaps what other people have clicked on. I might say, oh, this particular intent, we should also do some recommenders around, or personalization, or all those kinds of things. Or if you're in a consumer-facing situation, leveraging things like the head-tail relationships, looking at your relationships in your query. Now I can start to bring in information from those kinds of things. For those who aren't familiar with head-tail, it's essentially looking at your distribution of the frequency of queries. If you look at most, especially consumer-facing search applications, something like 20% of your unique queries make up 80% of your total query volume. That's the head. The tail, or the long tail, then, is all of the much more rare queries. One of the things that we've been working on here at Lucidworks is when you actually do an analysis of these head-tail relationships, you very quickly realize that a lot of the tail queries are actually related to the head queries. So if the head query is iPad case, the tail query might be, silver iPad Pro case with, unicorns on the front. Right? And oh, by the way, the user misspelled unicorns and they misspelled silver. That's a tail query, but it very much relates to the data and information we have at the head. Right? So essentially what I'm asking at this next stage is, what have previous users done before this particular user, and how do I leverage it? And then, of course, I can bring in all these user factors. Is this person a previous shopper? Have they been here before? Are they a highly valued customer? Are they a new customer? Are they in Florida, or are they in Canada? All of these kinds of things can be brought in. What security levels do they have, et cetera? And so now all of a sudden I'm starting to overlay into my request these types of factors. And of course, we can do a lot of different things here. We might then bring in some domain-specific rules, because I might look at the query intent and say, oh, this particular person's looking at jewelry. When we do jewelry searches, I then want to have these specific rules brought in because I'm running a promotion on diamonds this month, and so we're going to put diamonds up at the top. And then we go do our search just like we've always done, right? And so essentially up till now, I've essentially shaped the query that I'm going to ask of Solr. And then from that, I feed it into Solr. Solr goes and does its core retrieval, that core information theory thing that, at the end of the day, Lucene is doing underneath the hood. And then here's where it starts to get interesting, is Solr has recently added this capability around learning to rank. And this really then starts to bring in this next level of machine learning capabilities, whereby I take that coarse-grained retrieval that Solr does, and I refine it down. And if you dig into the academic literature around this, people often call this like a cascading ranking problem or re-ranking. If you're familiar with Solr, underneath the hood there's this query parser called the re-rank parser, or not query parser, but search component called the re-rank parser, where basically you can take, say, your top 1,000 or top 100 results and say, okay, I want the Lucene raw score, the BM25 score, but then I'm going to re-rank it according to some other criteria. And one of the criteria you can use is a learning to rank model that I've built off of user interactions, built off of features in the system. And so now all of a sudden we've gone from doing just one scoring of the content to perhaps multiple scoring of the content. In fact, some of our customers actually do multiple re-rankings here. They might use something like a logistic regression model to score the top 1,000 results, but then they might, on the top 20 or the top 50, they might have more expensive model. I've even talked to some people who have models just for 1 versus 2 or for the top 5, et cetera. You might also have learning to rank models for particular categories. And again, so all of these things kind of work together, right? So if I again, going back to the jewelry example, if I said this is a jewelry category that we're going to determine, we've determined that this user is interested in the jewelry category, I might then in Solr say load up my model for learning to rank that's just around jewelry, because I might have trained a model just in that space, right? So you can kind of see how all of this stuff starts to take that core Solr capability and add in a whole bunch of machine learning around it, leveraging all of the goodness that is in Solr around scaling and speed and all of that kind of stuff, but then making it smarter with this user feedback. And this is really, at the end of the day, what I think powers a lot of the machine learning or a lot of the better relevance. And of course, the last part of this is, and perhaps even the first part, there's kind of a little bit of a virtuous cycle here, or a continuous loop, in that one of the things that drives all of this, of course, is I've got to have a deeper understanding of my users. And if you look at most legacy ways of doing this, you often see this in a lot of, especially large companies, whereby marketing owns the users. They hand off that data to data science. Data science then goes and builds models of those users using R or Python or one of those kinds of things. And then they say, hey, I've got a better view of our users. Let's put this into production. Engineering looks at that and says, well, that's going to take me 2 months to actually put in production because I got to rewrite it in Java or Scala or some production language that they use. And so there's this long and laborious process of getting data in and actually learning from users. And we think that's kind of a shame. So what we do in Fusion, I'm sure you've heard it before, but these signals really are the key. And one of the things we just do is let's just make sure we can capture all of those into the engine. And so with Fusion, we capture our signals right into Solr underneath the hood. And if you're familiar with Fusion, I'll cover the architecture here in a minute. We then, again, load up into Spark. We've got a bunch of tools out of the box for doing query analytics. And then from those query analytics, we can go build out these richer machine learning models, the recommenders, the personalization. And then, just like you saw at indexing time, we store those models right back into the system. And then ultimately, we feed this back into the query pipelines, right? And its ability to process queries. So essentially the previous slide I was just showing you. And it's that process of us short-circuiting that long and laborious way of understanding users that I think is one of the critical differentiators in Fusion and one of the critical differentiators in building and deploying faster, more modern search systems. Right? All of this then, kind of at the end of the day, starts to look roughly like this type of query. There's a lot of different ways we can bring in all of this signal data, and of course I don't necessarily represent it all as a query, but I like this way of thinking about how I model out my request to the system, to Solr, to Fusion, etc., by thinking about how I'm matching across a wide variety of things. And there's a number of tools and capabilities ultimately at the end of the day in Fusion with Solr underneath that allows me to build these much more modern queries that bring in not only the core content matching, but also the machine learning, etc. So, up at the top here, we've got things like very highly precise searches. We want to make sure we get good candidates back to begin with. And so, making sure we set up things like our phrase swaps and all of that kind of stuff. And leveraging the capabilities in like the edismax parser and doing exact matches and all of that, of course, can give us that good first retrieval. And then depending if we want, if we're recall driven, we of course can add in other capabilities. And then kind of the bottom few here of this query really are where this kind of richer understanding of the data comes in. And that's where I can, for instance, leverage my word-to-vec models to do query expansion, synonyms. I can leverage my clickstream models to bring in priors around what users have done in the past. I can look at my relationships in the data around misspellings and tail queries. And I can start to shape the query, if you will. I can bring in personalization biases. I can bring in learning to rank, all of that kind of stuff. And, at the end of the day, I have, a query that represents all of the different components that I can then ship off to the core engine here and retrieve back results. And then, of course, I can also, do what we've always done, which is apply filter queries and any hard preferences or any of those kinds of things at the end of the day. So this is kind of my mental model around what modern search relevance looks like. There's obviously a number of different ways to implement this. The way we do this in Fusion isn't always just, hey, here, let's add on to the Solr query that we issue underneath the hood, but it's a good way of thinking about it at the end of the day. Out of all of this, where it really starts to get interesting, and when you really look at best in class here around modern relevance, is the ability of a company and of individuals working on search is to get out of the mindset of being right all the time. Getting out of the mindset of, I have to get this right because I only got one shot at it. And adopting a much more data-driven approach whereby they say, hey, you know what, I think this is going to work. Let's set up an experiment. Let's measure whether that experiment works. And then let's let the data tell us the story, right? You've probably heard of this as A/B testing. There's a number of other ways to think about it, multi-arm bandits, et cetera. I've got a link up here. I wish I could take credit for all of this. One of the things we're doing in Fusion, you'll see with an upcoming release, is a lot of experiment management just built in. Fusion 3.1 out of the box actually has some capabilities. I'll show you that in the demo here as well. But at the end of the day, what you're doing here is adopting an approach whereby you're saying, I'm going to try this out. I'm going to give a certain amount of traffic. This actually works not just in retail and consumer, but you can also do this internally with your own employees, et cetera, as long as you're careful about how you do this. I wish, like I said, I could claim credit for this. Microsoft actually has a really good set of talks that talk about how they build out their experiment management platform. It's the Bing group there. I know Google and Amazon and eBay and some of the other large internet companies out there have similar frameworks in place. But so if you want to get started, there's a link there that talks about how to go and dig in on this. All right, so at the end of the day, you kind of end up, you want to think about it as, hey, I'm going to use rules when rules make sense. I'm going to use machine learning when it makes sense. I'm going to use core Solr, core retrieval algorithms when they make sense. I'm going to combine them in lots of interesting ways. But most importantly, I'm going to measure and I'm going to let the data tell me whether I'm right or wrong. So that's all well and good. Let's actually dig in and show what this looks like a little bit at the Fusion layer. So I'm going to switch over to a demo here. Before we get to that, thinking about what Fusion does and how it enables this, I think there's a number of interesting pieces. For those who are new to Fusion, I kind of think about it as three key pieces, with the cloud here coming as a way of deploying all of this. I'll come to that here in a second. The first key piece, this bottom layer, the Fusion server. I like to think about Fusion server as it's all the plumbing, if you will. It's all the things that as a search engineer or as a developer, as somebody deploying search, that I have to do that I don't necessarily want to do. So it's ETL, it's connectors, it's security, it's how does Solr talk to Spark, it's the quote-unquote infrastructure, the scaffolding, if you will, that all goes into building a best practices application. The next layer for us is Fusion AI. This is essentially all the stuff that your developers probably want to be working on, but frankly are spending a lot of their time on the server, the lower level, the plumbing bits, because they thought they could do it better, right? And AI for us, very practically focused on how do we leverage machine learning, natural language processing, statistical analysis, A/B testing, experimentation to yield better and smarter access to your data, right? And then moving up the stack, we acquired a company back in May called TwitKit. That's been rebranded as Fusion App Studio. This is how do I build these applications smarter and faster. So all of these AI bits and the server bits are all plumbed in through that App Studio layer. I kind of think about it when it comes to developing an application as a developer, I now get to think about my application and my data semantically instead of syntactically. So a syntactic level of building an application without App Studio is, hey, I want an HTML text box, and I'm going to attach some JavaScript to it that calls this Fusion pipeline and passes in these 3 requests, and I've got to do all of this error handling myself. Semantically, in Fusion App Studio, you say, I want a search box. I want facets. I want type ahead. I want 10 blue links. I want paging. I want visualization of these 3 different facets, and I want it to automatically update when users interact. I've moved out of the realm of having to hand code all of these little tags, the core building blocks in HTML, and I've moved up to thinking about what is the functionality I want in my application, not what is the particular parameter that I need to pass in to hit this particular pipeline. And so I'm able to develop applications a lot faster, and more importantly, I'm able to develop applications by thinking about the feature I want in the application, not the feature of the technology underneath the hood. And then the cloud part for us, this is what we build our SaaS offering on it, Kubernetes, Docker, Fusion. Basically, how do we deliver this both in the cloud as well as on-premise? All right, and that's what, at the end of the day, enables us to actually ship this and build out on top of it. If you've been on any of my webinars in the past, you've seen this architecture. Real quick, though, on the right-hand side here, we've got a bunch of connectors out of the box. How do I get my data in? That data then lands in Solr. Solr is our database. Solr is the what do I need to know about my data right now engine, right? You have full and complete access to Solr. We're obviously, as the company who builds Solr, we want to make sure you have full and complete access to Solr. We then, though, marry that up with Spark. Spark says, how do I make my data smarter over time? How do I look at all of my data or a large quantity of my data? How do I build machine learning models off of that? And so, again, if you think back to this big picture here, right, I've got my core content, and right alongside it, I've got all my signals, all my user interactions, all of the feedback loops, et cetera, that I've captured. I can then take with this Solr Spark thing underneath, I can do joins, I can do all kinds of slicing and dicing, and that then allows us to build out things like recommendations, personalization, query intent, et cetera, much richer, much faster, right? Moving up into the right, server, like I said, is all of that plumbing layer around building out these applications. I'll highlight one really interesting, cool thing here in Fusion that we're going to have an upcoming webinar in, is that Fusion has a full and complete SQL interface, and that SQL interface actually goes well beyond the traditional SQL interfaces in that you have full access to all Solr syntax in there, so you can do really interesting and powerful text-based searches as part of your SQL queries, right? So imagine you're trying to assess the risk of a particular clause in a contract. You can say select star from all my contracts where the contract has this clause, roll up by customer, roll up by revenue, and all the traditional things that you do in SQL, right? And of course, that also enables us to deploy Fusion with tools like Tableau and MicroStrategy and Power BI and all that. Moving on to the left then, the AI. This is really what powers this much more modern capabilities. We have a number of things out of the box around clickstream, query intent, clustering, topic detection, A/B testing. The really cool thing here at the end of the day, as I like to say, is that if you have mathematicians already on staff, then they can plug in and leverage what we've built and extend it. If you don't have mathematicians, just use what we already built. So at the end of the day, pretty full stack, open and scalable at its core. We've got customers with trillions of documents in the engine, plugging in where they see fit. We then add in an intelligence layer. We add in a number of capabilities around business support, personalization, relevance, and all of that kind of stuff up the chain. So let's look at this. I'm not going to go do the full demo here because I think, I'll refer back people back to previous demos of Fusion that I've done where I've shown, this in the context of e-commerce. If you want to see this kind of stuff in the context of other types of use cases like enterprise search or customer 360 or financial, please reach out to us and we're happy to show you those demos. But of course, during a webinar, I can only do one demo. At the end of the day here, the cool thing here is I've got a product catalog. I've got a whole bunch of click data. I'm using Fusion 3.1, which has the Solr and Spark stuff, and then I've built out a UI on top of that, right, using App Studio. So let me switch over to my Chrome browser and just make that a little bit bigger. And I'm sure I need to log in again, so let me go do that. Like I said, many of you have probably already seen this, so I won't go through the full details. I'm just going to highlight a couple of key pieces going on with Fusion around this machine learning stuff that I'm talking about here. First off, this banner up here is using some of our experimentation capabilities, namely what we call multi-arm bandits. Multi-arm bandit basically says, go do an A/B test, but I want the machine to automatically learn which one is winning and then auto-adjust the results. So if you pay attention here, I'm actually going to hit refresh a couple of times. You'll see that it's showing tablets, Now it's showing TVs. Now it's showing tablets again. What's going on is that request comes in. It's actually hitting two key parts of Fusion. The first thing it's doing is saying to the experiment management system, what should I show? And all I do there is I put out a tag that says either TVs or tablets. And that putting out the tag is based off of an analysis of how users have interacted with this landing page to date. So if more people click on tablets, I'm going to show tablets more. More people click on TVs, I'm going to show TVs more. That tag then gets injected into the query pipeline, and downstream our rules engine picks it up and says, hey, I've got a promotion running for either TVs or tablets. Here's the 6 documents I want to, or the 6 products I want to show for TVs. Here's the 6 that I want to show for tablets. Moving down the page, user to item recommendations. Like I said, the same data, this click stream, this feedback loop, this is the same data that also makes for recommendations. So you no longer have to ship this data out to like a Rich Relevance or a Certona or any of these. You can build best-in-class recommendations using the same data that powers your search engine. That's what I've done here. This is a user to item recommender. The data itself is a little bit meaningless because the user here is just some anonymous user in the data set. But you can see they're interested in movies and music at the end of the day. I can come in and I can do my search, and I'll show you what this looks like underneath the hood in Fusion here in a second. A couple of pieces going on. I've just got baseline Solr search going on. I'm doing some keyword matching, and that's kind of the traditional view of search, that kind of first 50%. And I could go spend a lot of time tuning this, but of course I can go and do some much smarter things. So let me switch over to Fusion. I'm going to also make sure I've got a login here as well, and a good live demo. I can type. I can log in. I'm going to select my e-commerce collection. Some of you have probably seen this already, but what I'm going to do first is just turn on signals and leverage that clickstream model that we've built in Fusion out of the box because I've been collecting that user feedback data. I'm going to save that, and I'm going to go to my query again for iPad. And if you were paying attention, you noticed that all of a sudden we went from just keyword matching all the way through to we're actually doing keyword plus user feedback. And that really is that kind of first level of leveraging what do I know about users and their past, and then bring it into into the keyword context and enrich with what users have done there. And so you can see these results are a lot better. A couple of other things to highlight. I've done recommendations, again, off of that same data. Here they're query for query recommendations, people who search for this, search for that. If I click through onto a particular product detail page, you can see that I've got also now item-to-item recommendations. So again, with Fusion here, I'm just doing another query to the search engine. This really shows that power of those three additions, if you will, of taking and enriching the indexing data, enriching the query pipelines, and then learning from all the feedbacks to then power smarter search, better recommendations, all of those kinds of things, right? If I go back, I can do one more layer here. I'm going to turn on a index pipeline now that has query intent built into it. And if I can actually scroll and find that one, here it is. This one has e-commerce. This has all of the signals, plus it has query intent in it, and it actually even has learning to rank. So let's look at that real quick in the Fusion Query Workbench, and then I'll show you what those results look like. So if I bring up that pipeline here, I'm going to load it up. My pipeline is pretty rich at this point. Namely, I've got, just like in that diagram that I showed, the very first thing I'm doing is trying to predict what does a user actually care about when they do a particular query. And I've built a pretty simple model here, just looking off of the distribution of clicks across categories. So I'm not quite doing a full intent classification here. I'm doing a prediction that says, what is this category most likely affiliated with? And then I'm applying, for instance, the filter to it, and then I'm turning on Solr's learning to rank and all of those kinds of things. So if we do that same iPad query here, for instance, and I can show you this in the UI as well, but you can kind of see I've got back a lot of those same results, and they're all, pretty well focused within iPad. And then I can start to play around with these things, right? So for instance, I've done this classification. I can turn off my filtering. I can turn off my learning to rank, all of those kinds of things, right? And so a much richer pipeline now that at the end of the day says, let's predict what users want. Let's turn on some features in Solr, depending on what those users want or what I'm trying to achieve. I've got learning to rank in here with just simply, do I want it on or off? But you could imagine having, taking that query intent label and saying, oh, this was a tablet category intent. Let's use the tablet learning to rank model that I've built, right? And then down here, I'm starting to leverage clickstream, and I'm saying, hey, what have previous users who have this intent and have done this query, what have they done? And let's bring in that information such that I can feed it in downstream. And then I've got my rule system set up, and then ultimately I'm going and doing a Solr query, right? So again, this allows me to build this much richer, more modern approach to search. As you'll see coming out in 4.0, we've got a whole bunch of goodies in store for you around how do you measure these things, how do you do query analytics on it, all of that kind of stuff. Let me hit on a couple of other things. This is one of the coolest things about all of this stuff with Fusion. As you know, with Solr underneath, it supports multiple cores, multiple collections. Likewise then in Fusion, we leverage this to really drive this richer experience, this short-circuiting process between user feedback, machine learning, and all of those goodies. So at the end of the day with Fusion, we keep all of this right in the same place, namely in Fusion. That means you can search and access it the exact same way you do your core content. And that really is what enables you to drive more experiments, right? Because now I could set up one or more pipelines and you can say, okay, does this query intent pipeline perform better than just Solr out of the box, or just this this little tweaking that I've done, or does this rule perform better than that rule, or does this experiment, perform better, right? And it's all stored right in there, so your search developers, your business analysts, all of these people can interact with the data in the same way. So for instance, here's my rules collection, and I can search and access that the same way. This particular one shows boosting, right? My recommenders that I showed you that are built off of those raw signals are all right in here as well. So for instance, that query-to-query recommendation that I was showing you, I can look and introspect that data as well. People who search for CD cases also search for PlayStation 2, or people who search for Xbox controllers were also looking for Razer laptops. All of that data is accessible to you in the search context. And in fact, to kind of round out with the indexing side of the equation, let me just show you how I built that machine learning model that we talked about. And I'm going to do that by selecting this training collection. And that training collection, well, I haven't actually built it here locally. Let me just show you the jobs. Sorry about that. That training collection consists of me doing two key things in Fusion. First off, I wrote a little bit of Scala code that says take my core product catalog and join it up with my signals data, and then analyze the distribution of clicks across categories. So people who queried for this ended up clicking in this category, not even just on this particular document, but on this particular category, and then we do some trimming and cleaning of that, and we output it to a collection, and I could go ahead and run it here, and you would see it in the search results. That data then gets fed into me saying, I want to build a machine learning model off of that, in this particular case, to predict the category of the user. So for instance, I now take that data in that training collection, I say I want to learn off of the query data, and I want to predict the category data. And then I run this job, and it outputs that machine learning model into Fusion, which I then load up into that query pipeline that we were talking about earlier here, namely right here, right? So that's kind of a round-trip view of all of this data, and I'll leveraging the signals and the machine learning and all of those kinds of things. And of course, there's a lot more you can go and do with that, but in the interest of time, I'm going to go back and just leave you with a few resources around if you want to try this out. Like I said, I've shown you this as an e-commerce demo, but we also have it for enterprise search. We have it for clinical data, financial data, et cetera. And there's a lot of different ways to think about how do I leverage this machine learning and NLP, this quote-unquote AI stuff, to make all of this better. All right. So with that, ends the core content for the webinar. As I always, want to thank you for joining. Happy to talk with any and all of you. Just reach out via sales, via the contact information here, via the webinar. With that, Ali, I'll put it back to you, and happy to take on a few questions.
Great. Thank you, Grant. We do have time for just a few questions, so we'll just get started. The first question is, are these capabilities only for structured data?
Yeah, that's a great question, and I guess it kind of depends how you think about structured. Or what structured data is. It's a little bit of a pet peeve of mine, because text is actually very highly structured, and a lot of these techniques can be applied for text as well as more structured data, right? So some of the, like for instance, that query intent classifier, I'm building that off of the text data in the query, but then I'm predicting a category, which of course is structured, because in this particular data set, there's only so many categories. It's not just a free-form taxonomy. So with all of this AI stuff, right, there's a lot of bits and pieces underneath the hood, ranging from things like NER, named entity recognition, which are geared towards dealing with text, through to, for instance, clustering and some of the classification capabilities that can go both on structured and unstructured content, really depending on what features you leverage. If you dig in on the learning to rank capability in Solr, which is still in the early stages but improving pretty quickly and has a lot of good capabilities out of the box, it can leverage a number of different features ranging from, for instance, the score that Solr retrieves for the candidate retrieval all the way through to things like pricing or inventory or other factors up through to the actual text on a particular document.
Thank you. The next question is, does Fusion collect search terms along with country names for geolocation analytics? And how can we show predictive search based on country specifics?
Yeah, that's a great question. So with the signals, and I can perhaps just show you, because these, the cool thing with these signals is they are just yet another document in the search engine. In this particular data set, I don't have geolocation, but for instance, if you're using our App Studio, we can capture all of the IP and do reverse IP lookup and all that kind of stuff and factor that in. And at the end of the day, we just add those on as fields in the document. And then, of course, at query analytics time, you can do roll-ups based off of, essentially you're grouping by, location, by session, by however you want to slice and dice. And that's kind of that power of the SQL engine that powers all of this stuff that I alluded to earlier. And then at the App Studio layer, we have mapping and charting capabilities built in. In fact, we have some Customer 360 demos that do exactly that, of looking at customers across locations, looking at the transactions they make. And it's a really nice complement to something like a retail demo where you're actually looking at both the front-end experience of search and then also the operational intelligence side of the experience. And you're building out this, this platform that can leverage all of the data that you've captured in Fusion to build out a number of different applications. But yes, I guess is the short answer.
Thank you. So we're just coming up on time. If you asked a question and we didn't have a chance to answer it, someone from the Lucidworks team will reach out to you. Everyone who registered for this webinar will receive a link to both the recording and the slides shortly. And if you have any additional questions that you didn't get a chance to answer or to ask, feel free to shoot us an email at events@lucidworks.com. Thanks again for joining us today, and we hope you enjoyed the session, and thank you, Grant.
Thank you, everyone.